So to get away from bias sampling, what we're interested in is using something that's unbiased. What we're going to look at is a simple random sample to start with, frequently referred to as SRS. What that does ensures that every sample of the intended size is given the same chance of being selected from the population. Thus, every observational unit has the same chance of being selected. So, unlike what we did before, where I asked you just to choose words, and in most cases, it's easier to see and to grab the word like larger than it is to grab the word A. But we want A to have an equal chance of being chosen as the word larger. There are many ways to take a simple random sample. Generally, what we can do is assign a unique ID to each observational unit and then use a random number generator to generate the IDs to be selected. Now, I did this all the time as a CPA. We would get the check numbers, and of course, from a client. We would then verify using the bank statement because you trust but verify as a CPA. And let's say they had numbers 1 through 1,000 for checks. We would then generate using a random number generator. We would select 25 to be sampled to check all of the background information, the invoices, everything that they had to make sure that not only was it properly accounted for in the records, in the financial records, but also that they're following the procedures that they have in place. So what I'm going to do is I'm going to show you how to use the random number generator in the applets. I suggest you do it too, and then you can try it along with me. So I'm going to pause for a moment. Now, I'm sharing instead the Canvas page. If I click on Web Applets, it'll come up. You always have to then click on the Web Applets again. Now you'll see random number generator under probability, and I can just click on that. Number of replications, number per replication, and the number range. So we're only going to do one replication at this point, so I just want to come up with one set. Numbers per replication. Well, in this case, I'm going to do 5. The number range is from 1 and to the total size of the population, and that is, if I remember correctly, 268 words. So we want any one of the 268 words to have equal chance of being selected. Do we want to replace the word and have it possibly be done again? No. So I'm going to generate that, and there are the results. If you want to, you can also sort. So I'm going to generate another set, and you'll see it's from small to large, and that's actually an easier way to do it, honestly. Will I get, every time I generate, will I get a new set of numbers? And the answer is yes. Could I possibly get the exact same set? Yeah, but it would be fairly unlikely. So that's how to use it. Now, I would suggest trying this yourself, coming up with these numbers and recording them in the ID number line. So when I ran the random number generator, I've got 44, 192, 266, 239, and 118. And you may say, well, okay, great, but then I have to go and count the individual words. That's going to be a pain. You actually don't. What you're going to use instead is this table here, which shows that word number 1 is 4. Word number 17 is conceived. So if I wanted word number 44, I would go, well, let's say this is 47, so 46, 45, 44. So word number 44 is or. And that's what I recorded here. It has 2 letters, and does it have an E? No. I then did that for each of my words, figured out where it was, 192, go to, let's see, 192 would be after 187, so 187, 188, 189, 90, 91, 92, and that's the word 2. So please, if you did do the random number generator, please complete this chart. If not, go ahead and use my numbers to complete it. So there it is. Compared to what my words, now this is only 5 versus 10, but I noticed that there are more small words, which makes sense because there are a decent number of small words in the Gettysburg Address. The key here is that simple random sample makes every word equally likely to be chosen as any other word. Doesn't matter what the length of that word is. If I find the average, I'd add up the count to 2 plus 2 plus 4 plus 4 plus 6 and divide it by 5. And I get 4.4. And the p hats in this case is 0 because I didn't have any words with the letter E in them. Now, recall that the average of all 268 words in the passage is 4.295, and the proportion with E is 0.466. So I know what mu and P are. What proportion of your class got a sample average X bar? Sorry, this should be right over the top here. That should be X bar is less than 4.295 and more than 4.295. And in the classroom, what I do is I'll say, okay, who got less than 4.295? Who got more than 4.295? And generally, it's usually split about 50-50. So it's unbiased. For D, what do your answers from D imply about simple random sampling, biased or unbiased method? Simple random sampling is unbiased. Why? There's just a few observations there. It gives us a balanced view. It's roughly a 50-50 split between those that are under the average, the population average, and those that are above the population average. So it gives us a balanced view of what we have, and what's actually going on. Next, we'll talk about sampling methods.